In this video, we are going to create the smart contract for our flash loan. This smart contract will have two responsibilities. It will first execute the flash loan arbitrage and second, withdraw the profits. So we said before that we're going to use DYDX for the flash loan, but DYDX doesn't actually have a flash loan feature. However, we can still reproduce a flash loan by leveraging the way DYDX works. So DYDX works with actions. In a single transaction, you can combine several actions like deposit, trade, withdraw. The trick is that DYDX does not check balances until the very end of the transaction. So you can withdraw money that you don't have as long as you reimburse it before the end of the transaction. And you can also call any arbitrary function on any smart contract in those actions. So to do a flash loan, we'll first use the withdraw action to borrow our flash loan. Then we will call a function on the same smart contract, and in this function, we will have the arbitrage logic. And finally, we will use the deposit action to reimburse the flash loan. Interacting with the smart contract of DYDX is not very easy, but fortunately, there is an NPM package that makes it easier. So that's called Money Legos. So we are going to install it. So in your terminal, at the root of your project, we're going to install this study DeFi Money Legos. And after, in your code editor, we're going to create a new file in the contracts folder. We're going to call this flashloan.sol. And we're not going to start from scratch, but we're going to copy paste a snippet from the Money Lego package. So you go to the website of Money Lego, you'll find the links above the video. And in the DYDX section, we will copy paste this snippet here. So that's at the very beginning of the page. You copy paste this thing. I'm going to explain exactly what it does. So here it declared a version of Solidity, so it uses Solidity 0.5. This thing is to activate certain feature of Solidity. So this import statement allows to inherit from other smart contracts that were defined by this NPM package. And here, this thing allows to interact with ERC20 token. OpenZeppelin is a very famous Solidity library that is used internally by Study DeFi, so we don't need to install it separately. And after, we have the smart contract of the flash loan itself. So we're going to change this to flash loan so that the contract has the same name of our file. So first, our smart contract inherit from these two other smart contracts, so that allows to already start with some functionality built in and to go a bit faster. Let me scroll down. So we have two functions here, call function and initiate flash loan. So the whole process starts with the initiate flash loan function. So we give it the address of DYDX, the address of the token we want to borrow, the amount. So after it initiates a pointer to the smart contract of DYDX, it gets the market ID. So depending on which token we want to borrow, it's going to have a different market ID. Then here we get the repayment amount. The repayment is slightly different from what we borrow because we have to pay two-way, but that's a very, very small fee. Then here we build an array of operations. So total, we're going to have three actions. The withdraw action, so that's when we borrow the token from DYDX. The call action, so that's when we do any arbitrary smart contract execution. So that's where we're going to have the arbitrage logic. And finally, the deposit action, that's when we pay back the flash loan to DYDX. And here, what's interesting in the get call action is that we can pass any arbitrary data to the function we're going to call. So here we just have to define a struct, and it's going to pass it to the receiving function. So here the struct is defined at the very top, my custom data. And we're actually going to modify this. We're going to call this arb info. So we're going to keep repay amount, but for the token, we're going to change this. We need another info, which is the direction of the arbitrage. Is it from Kyber to Uniswap or from Uniswap to Kyber? So for this, we can use an enum. So an enum is basically like an option. It can have different value. So we're going to call this direction. And we're going to have two options. First one is Kyber to Uniswap, and second one is Uniswap to Kyber. And here we replace this by direction. So the type of the field is direction and the name is direction. So here we have this data structure with two fields, direction and repay amount. So based on that, we're going to modify what we have in Flashloan. So here we pass this 3 argument, and we're going to need another one that we're going to call the direction. And after, when we get call action, here we're going to pass our struct, so app info with the direction. And the repay amount is the same. And after we scroll up to the call function, the call function will be called once we have withdrawn the token from DYDX, and that's where we're going to do the arbitrage. So we get a couple of info as argument, and here for the data parameter, that's where we're going to receive the arb info struct, and so we need to decode it. So by the way, if you wonder why we're doing that way, why we use this byte string, can't we just pass directly a struct? It's because this way of passing parameter is much more flexible. So the people who created the Money Lego NPM package don't know exactly which data we want to pass. So they cannot decide in advance what's going to be the struct here. So instead, by using this bytes method, they make it much more flexible, and we just have to define any struct we want and we can decode it, and we decide what's the shape of the data. So here we're going to decode this arb info struct, arb info, and for the rest we're going to delete this for the moment. After, we're going to fill it in the next videos. It's where we're going to put the arbitrage logic. So we're going to stop here. In the next video, we're going to add the addresses of the different smart contracts we need to interact with. So the tokens and the exchanges, so Uniswap and Kyber.